All right. Hey, Monday the 7th. We are this week going to finish up looking at chemical reactions. We're going to look at a couple of specific ones because we're going to predict what the products will be. And then we're going to do things called net ionics on ionic equations on Thursday. And then we're going to start our stoichiometry unit on Friday. Okay. So let's go ahead and get started. Today is kind of looking at single replacement reactions. In fact, you're going to watch a lab demo and take down some data. So you have to watch this to understand what exactly is happening. I got to move this. Okay, so when we look at a single replacement, if you guys see this, hopefully you can, is that you have one standalone metal, or it could be a gas. Okay, in this case, it's potassium, and it's reacting with water. Okay, and what's potassium's doing, because it's more reactive, is it's kicking water, the hydrogen out. So it kicks the hydrogen out, and basically they switch places. Okay, so you end up with potassium hydroxide and hydrogen gas. Remember, hydrogen is a diatomic. All right, so that's what we're looking at, is these switch places. Boom. Okay. All right, so here is what the kind of the ABX sort of equation looks like. I know they use C's in your workbook, but what happens with a single replacement is an uncombined element, okay, whether it's a diatomic gas or a metal, can replace the other cation and creates a new compound. Okay, so A and B switch. Okay, so A is the uncombined element in the reactant side. BX is the ionic compound. Remember, you're going to need your ionic charges chart or sheet. Okay, and if A is more reactive than B, it's going to replace it in the solution. Okay, so we're going to look at what that means. And I'm going to show you an example of one. Okay, I just have to pop up the video, but we're going to look at this. This copper, okay, is going to replace silver in the silver nitrate solution. Remember, aqueous means the solution, and what you're left with is a silver precipitate. It's a solid, and copper nitrate solution. Okay, so I'm gonna go ahead and show you the demo. I'm gonna have to. It's gonna come off here for a second. There it is. Okay, so here it is. Hey, I want to show you a single replacement reaction because we're going to do I'm going to do a lab demo, but I want you to give you an idea of what we're looking at with a single replacement. We're going to be doing, I know it's hard to see, I'm going to bring it up. We're going to be doing copper, okay, and then a silver nitrate solution, okay, going to silver and copper nitrate. Okay, so that's what it looks like. Okay, I have it in the screencast, this reaction right here. Okay, so what we're going to do is we're going to try and see if we can make, if copper is going to replace the silver nitrate. So what I have here is I have silver nitrate, very clear colorless solution, right? Okay, and I'm going to take my copper, okay, and bend it up a little bit, copper wire, and I'm going to put it in the test tube. First of all, silver nitrate is it will stain really easily. So just to prohibit any kind of spills, I'm going to put a stopper on it. Okay, so right there, I put that in there. You notice there's nothing really happening. But about 5 minutes ago, I did one. Okay, it's the same thing. And what you're going to see on the outside of along the copper, you can see the copper above. The copper right there, you can see precipitate. That's silver precipitate forming. So what happened is the copper replaced the silver in the solution, and what you're left with is that silver precipitate. Okay, so that's kind of what we're doing today. We're looking at silver, but at single replacements, and right there you can see it's starting to kind of form the precipitate forming. So that's what we're looking at. So copper did replace the silver in the solution. Okay, because it is. Okay, so this is the same thing I did it, or when I videotaped this. you can see how much silver precipitate has been formed. Now, that's not real silver. No, you can't refine it and make a silver earring or whatever, or ring. But it is a silver precipitate. Okay, and you notice that the solution now is a little bluish color. Copper solutions are blue. Okay, that's a okay. I'm going to change. I got to keep moving this around. All right, so that's what we're looking at with single replacement reactions. Okay, so what you're going to see, we're going to do a lab. I'm going to show you a demo lab. It's only going to be like 3 minutes long. So we're going to look for production of bubbles or gas. Okay, some sort of gas formation, the obvious color change, or any kind of precipitate, like we saw with this one. So I'm gonna do. This is the table that's in your worksheet. So have that out. Make sure you have that out. Okay. And I am going to go ahead and actually we're going to end up filling it out afterwards. But I want you to watch the demo, because this will kind of explain to you how this happens. So here is the lab demonstration for today with the single replacement. All right, here's your single replacement demo lab, and in your worksheet for today, you have a table, and I kind of explained to you what we're doing here. I'm going to do a quick explanation. We're going to look and see how reactive metals are. Okay, and what we're going to do is we're going to test three different metals. We're going to test iron, we're going to test magnesium, and we're going to test copper. And we're going to test them against solutions of hydrochloric acid, 0.1 molar hydrochloric acid, 0.1 molar copper chloride. You can see it's blue, copper. And then 0.1 molar magnesium chloride, and then 0.1 molar iron chloride. Okay, so what we're going to do is we're going to test those things. And then we're going to set up, I have a little well plate here that I'll show you. It's right here. Okay, and in it, I have the metals. Okay, I can't really see it, but there's metal sitting in here. I have them set up just like this, where I have over here, I have copper. It's going to hydrochloric acid is going to go in it. And we're going to skip that. We're going to make copper, like magnesium chloride, copper with iron chloride, and we're going to get every combination we can with what we have here. Okay, so we're going to see how reactive these three metals are, and we're even going to look at hydrogen. Okay, so here you go. That's what I'm going to do. I'm going to go ahead and all I do is just drop it into the metal tray, cover it up. And I'm looking for precipitate, a color change, gas formation, anything like that that's signifying that there's a chemical reaction. All right, I'm going to go ahead and set this up, and I'll let you know what we do. I'll try and show you this without moving around too much. Okay, but we're going to go ahead and look and see what we got here. Okay, if you look here, this is the copper and hydrochloric acid, no reaction. You don't see much happening. Here you see gas formation, that's magnesium and hydrochloric acid. Here you have the iron and the hydrochloric acid. You can see a little bit of bubble formation there, not quite as much, but a little bit. Okay, and then if you come, we're going to keep going down. Now we got the magnesium and the copper chloride. You can definitely see bubble and color formation precipitate. Here you can see a little bit of rust formation. That's the iron and the copper chloride. Okay, hope you can see that. I'm trying to hold it still. Okay, and then here, no reaction. Okay, here, no reaction. And that's with the magnesium chloride. No reaction with the copper here, with the copper and the iron. And then here you have the magnesium and the iron definitely reacting. You got gas formation. You even have some precipitate formation. Okay, so that's what we're looking at. All right. So let's go ahead and fill out our table. Okay, so we're going to fill this out together. All right, and I'm going to give you the data that you just saw. Okay, let me make sure I got my data in front of me so I don't forget it. All right, so what we saw, where'd it go? Oh, there it is. So here with copper, we saw no reaction. Okay, in fact, we saw no reaction. NR means no reaction. We saw no reaction with all the copper in the solutions. Okay, then with magnesium, we saw a precipitate. It's like a black precipitate. Okay. Here we saw, and we saw some gas formation. Here we saw with this one, we saw also again some kind of darker precipitate. I'm just going to say darker precipitate. PPT remembers precipitate. And here we saw like a rust color precipitate. Okay. With the iron, we saw a gas formation. Okay. There was definitely bubbles forming. Okay. We had kind of a red precipitate. It was hard to see. It had to let it sit for a little bit. And here with the magnesium, we had no reaction. Okay. All right. So we had none of the copper reacted with any of the solutions. All the magnesium reacted, and 2 of the iron reacted. Remember that, because we're going to kind of look at that and what that means here in a second. Okay. So if you remember, what we just used is we used copper right here. We used hydrogen, which used hydrogen and hydrochloric acid. We used magnesium, okay, and we used iron, right? So if you look at this, we saw all the magnesium react. If you look at this is called the activity series. The more reactive, as it goes down the list, the less reactive the metal is. The more reactive the metal is, it is going to then bump out. If it's standalone, it's going to bump out what's in the compound. Okay, the ionic compound. Okay, so what we did is we saw magnesium bump out all of those positive anions, positive cations from their ionic solution. Okay, iron, we saw it happen twice. Copper, we didn't see it happen at all. Okay, that should tell you something. Why do you think copper is so valuable? Why do you think silver is so valuable? Why do you think mercury is so valuable? It's because of the fact those are non-reactive metals. Okay, they don't react. Okay, so hydrogen was a part of that. It was part of hydrochloric acid. Okay, so we should have seen this sort of activity or reactivity series when we looked at what we just did. Magnesium, most reactive. It reacted with all of them. Iron reacted with 2 of them, two of the 3. Hydrogen reacted, the hydrochloric acid reacted with all but the copper. Okay, and notice copper is not there. Copper is at least reactive, and we saw nothing react with copper. So how this works is we're going to go ahead and do this. So we have zinc, okay? We have zinc metal, it's a solid. We have copper 2 chloride, okay? Now, is this going to happen? If we come down here, let me erase this. Where's my eraser? Oh, okay, I'm going to come back. Pen. Okay, so now we're going to take zinc, okay, and we're going to put it into a solution of copper 2 chloride. Okay, the question is zinc more reactive than copper? And if you look here, it is. Okay, zinc is more reactive than copper. So that reaction is going to take place. So what's going to happen is zinc chloride is going to be produced, plus what's going to be left over is going to be the copper. Okay. All right, so all they did was switch places, right? And that's kind of how it works. So let's try the next one. We have iron, okay, we have calcium carbonate. Okay, so this is what we're looking at. So if you look, we have iron right here, and then we have calcium up here. Okay, is that reaction going to take place? It is not. It's not. No reaction is going to take place because the iron is less reactive than the calcium. It's not strong enough to bump it out of there and become a part of the solution. Okay, now we can also have this happen with gases. So here we have F2 or fluorine gas, okay, and then we have chlorine here. This is the positive anion. Remember that. Okay, so now we have an activity series for halogens only. Okay, so halogens can be a part of this. So if you look, we have fluorine, and it does go in order, okay, going down. So fluorine sits up here. It's the most reactive. We know that. Okay, and chlorine is the next one down. So the question is this more reactive than chlorine? And it is. So it is going to bump it out of there and change places. So it's going to be NaF plus Cl2. Okay, so all they did was switch places. That's how the single replacement reactions work. And you guys are going to have to do a few today. just kind of, you're going to have this activity series, and you're going to have to predict whether or not the reaction is going to take place. Now, we got to make sure we're balancing these things out too. So we have 2 fluorines. We have 1 here, so that could be 2 there. We have 1. We have 1 sodium here. We have 2 there, so we got to put a 2 there. We have 2 chlorines here. We have 2 chlorines there. There, that's balanced. If we come up here, which I was reluctant in telling you, this is already balanced out, right? Okay, so we're all good with balancing. All right, so what you're going to do today is you're going to go ahead and fill out this worksheet or the lab sheet, and then you're going to do a few reactions. Okay, that's today.